Yet another beautiful morning here in southern Wisconsin, across the whole state. In fact, I don't think we've had a warmer sunrise in months than we just did today. I think it was over 40 degrees, 41 degrees at my house. And there's almost no snow left on anybody's lawn in my neighborhood as I'm looking out the window. And also, as I mentioned on Friday, without puddles. So it's just been a very persistent and rapid disappearance of what we had of 15 or so inches of snow cover at the end of February. Simply unbelievable how this has gone so quickly. And it's just a beautiful day. The eastern half of the United States is dominated by high pressure. As you can see, this big series of H's in the region of high pressure sitting over the Carolinas, but it stretches all the way from southern Quebec back to Louisiana and eastern Texas. And this whole region of the country, therefore, is kind of weather-free, as it were. Huge spacing between the white lines, which are sea level isobars, lines of constant pressure, which indicates, as we had over the weekend, absolutely no wind when the pressure, when the distance like it is in these pictures is so wide. And that's true even when you go all the way over to the West Coast. Frankly, there's no place in the United States today that has any substantial wind episode, and there's very little organized weather. There's a little bit of rain in New Mexico and Arizona. There's a little bit of snow in Montana, parts of Idaho, and some features of interest off the Pacific Northwest coast, but that's it. This is a pretty nice day across the whole country, and starting out in many locations relatively warm, as we'll see in just a second. Absolutely spectacular day. And here's the temperatures across the country. Look at that. Madison, 42 degrees at 7 a.m. local time. That's unbelievable. 36 at Green Bay. Probably a little colder there just because you're near the water at this time of year. And really nice. The whole central plains region in the low 40s to begin the day. No chance really of any substantial cloud cover, so we should see temperatures approaching 60 degrees today. I wouldn't be surprised if we get there. I wouldn't be overly surprised. I'd be a little surprised. I think we'll probably end up somewhere in the mid 50s, but still probably the nicest afternoon of the year thus far. And if you were out on the weekend, you may have noticed that the temperature, it didn't feel very cold, but if you looked at a thermometer, the temperature really never got very high. It didn't get, I think, even to 50 degrees. And we were out in a wide open field out west of town taking a hike. And if it had been the slightest bit windy, it would have been really chilly outside, even with the bright sunshine. But there was just such an absence of wind that even on a day where the temperature didn't quite get to 50, it felt just great outside. It's going to be even better today because we'll have both the higher temperature, the brilliant sunshine, and the lack of wind that was characteristic of yesterday. So look at the temperatures all the way across the central part of the country. They're starting out nearly uniform. It's 39 in Shreveport. It's 32 in Jackson, 48 in New Orleans. So it's not really warm on the northern coast of the Gulf of Mexico, but it's going to be a nice day down there. It's a beautiful day for us because we're not used to it being so warm. But places like Jacksonville, 40 degrees, that's chilly for Jacksonville, Florida. Perfect for us at this time of year. 50 at St. Pete, 56 in Miami to start the day. That's really cold for Miami. And you'll see some other evidence of that. And pretty chilly over New England. Temperatures in the single digits as far north as in Caribou and 11 degrees at Burlington. Other than that, around 20 everywhere else. And then it's earlier in the morning on the Pacific Northwest coast and the coast of California, but it's still very, very nice there in 66 in Phoenix. Or is it 65? 65 to start the day. So pretty nice. Now today we're going to introduce a new chart that will carry with us throughout the rest of the term, and that is based on what we've been talking about in lecture, the dew point chart. So here is the current dew point map, or 7 a.m. local time dew point map, I should say. And so you get an idea what the dew point temperatures were like in places like St. Louis, 31 degree dew point. I think the actual temperature was in the 40s, so we're not at saturation. You'd have to have temperature and dew point being exactly the same to have the air be saturated. Down near the Bight of California, south of Los Angeles and San Diego and LA, I think we had temperatures in the very low 50s, 56 at San Diego if I recall, 48's the dew point. So you're closer to 100% relative humidity there, but not quite at 100% relative humidity. And here in Madison, as you remember, it was 42 for us, and we're 30 degree dew point. So there is water vapor in the air. It's just not even close to being the amount that would saturate the air. And remember when it was cold, I think Caribou, Maine was 7 degrees. It has a dew point of 0. So it's still some substantial distance between the temperature and the dew point, indicating a lack of saturation. So almost no place across the country is saturated today. I think the color code here indicates dew points that get above 40 degrees. I think that's what the green means. Now I'm going to try and save this map for other days because there will be days in the spring term when we have a few weeks left together, where we're going to see dew points in the 60, maybe even 70-degree Fahrenheit range down over the Gulf Coast. We may even see 50 or 60-degree dew points up near us by the time the term is over. And you will notice a substantial difference in the comfort level if you go outside on a day when the dew point is nearly 60 degrees versus today when it's 30. You wouldn't notice. If you even went out to play basketball or some other thing in the active, took an active period of time this afternoon to do something outside, it'd be really difficult to break a sweat because there's so little water vapor in the air. As soon as you perspire, it's going to evaporate into the air. But on days when the dew point's higher in the spring, you'll find it a lot harder to shed that perspiration, and that's when you have the risk of overheating. So with the low dew point like we have today, there's no risk at all. It's going to be an absolutely beautiful day. And that's true especially in the South, where they're used to pretty warm days in early March, but they're not used to really dry days. This is a great example of an absolutely spectacular day, the kind you'd hope to be down there for, where it's very warm, but the dew points are very low, so it's not muggy. And so that's a nice benefit for our southern fellow citizens today. Here's the satellite movie across the continental United States and adjacent waters. And as you might guess, based on the discussion that's preceded this, there's really not much active weather, especially in the eastern, let's say 3/5 of the country, all the way from the border of the Dakotas into the plains of Colorado and then most of the state of Texas to the east. Nothing at all in terms of the cloud field, and that's unsurprising. We'll see that's reflected also in the radar. A pretty decent storm developing off the east coast of the United States, and that will be heading, it looks to me like it'll be heading straight to the northeast, south of Greenland towards the British Isles over the next day or two. And whether or not it stays together and maintains a level of intensity is another question, but that seems to be the direction in which it's heading. And then there's a sort of a not so well organized but weak cloud band coming across Baja California into Arizona, Utah, parts of western Colorado, northwest New Mexico. I don't remember if that's precipitating. We'll see when we look at the radar together in just a minute. And then you can see, again, open cellular convection, this sort of popcorn-looking cloudiness off the coast of California. Between that region of cloudiness and the coast itself is a rather more continuous band of clouds that parallels the coast, and we'll see a better view of that on the West Coast radar in just a second. So overall, conforming with what we saw in the prior part of the discussion, a pretty nice day across the country. There's certainly no organized weather systems affecting the United States. And this is evident again in the radar summary over the last 5 or 6 hours. There's a little bit of lake effect type snow coming across parts of southwestern Ontario and then into western New York State. Here's some of the radar echo across Arizona. It doesn't even really survive into Utah, Colorado, or New Mexico, but that's what we saw in the cloudiness in that portion of the globe just a minute ago. And a stray shower or two in Northern California. And then here's a fraction of the showery activity that's coming in with that continuous band of clouds along the west coast, paralleling the coast more or less to the west, and then coming in far enough east so that the radar on the Washington coast can start to see it. But it's probably more widespread light precipitation than is indicated here. One other thing I want to point out is watch these set of radar sites across from Indiana all the way to western Iowa. There's a certain period of time that they kind of all light up in sequence, first in the east and then here and then further in the west. And that is, there's no precipitation and no really meteorological or hydrometeors to be detected by the radars. But what they do detect is sunrise. So remember, these radars are sending out a particular kind of electromagnetic radiation, and then it bounces off precipitation particles, and whatever is reflected is what tells you what's out there, and that's called reflectivity, radar reflectivity. So the radar sites are not only transmitting radiation, but they're also receiving it. So as the sun peaks above the horizon on a clear day like today, there's a burst of microwave radiation. And that, because that's part of what the sun is shining on us, and that burst is reflected in the receiver. And so boom, there's the sunrise. And then when it gets above, the angle of the radar points at about ½ degree above the horizon. So very, very shallow angle. And so that burst only happens at one moment. And then the sun rises above it and you don't have that big burst of radiation. So you can actually see at what time the sun rises at all these locations. And it is in sequence from east to west. See that? So that's kind of cool. Just a little nerdy thing about the radar. And then finally, here's our West Coast satellite image. So we get a nice view of this storm out off the Pacific coast. And it seems to be, I'll put my cursor right in the middle of what I think is the center of it. It's barely moving. That's the center of the counterclockwise rotation. And so the fact that that center of the circulation is hardly moving anywhere probably means these clouds are going to take a very long time making slow eastward progress toward the coast. So much of, as we just saw on the radar, much of the Pacific Northwest coast is not yet experiencing precipitation, and it might be several hours before it actually does. So that's going to take a while. This popcorn-looking cloudiness on the western side of the continuous cloud band is a function of the air being really cold at levels above the surface. And we're going to talk about that this week when we examine the concept of stability of the atmospheric stratification. So we're just on the precipice of talking about that. And here's a really intense cloud feature that's coming all the way from the central Pacific up into the northern part of the Bering Sea and spreading clouds over western Alaska. And then one other feature is the one that we saw, it was reflected in the radar over Arizona and parts of Colorado and New Mexico, and that is a cloud streak that comes all the way from the deep tropics. This is well south of the state of Hawaii, which is right here. So that's the northern boundary of the northern hemisphere tropics. So this is a tropical plume of moisture that's heading into the desert southwest of our country. And that's a kind of a characteristic of this time of year, and sometimes leads to the spring rains that spawn the bloom over the desert. It doesn't last too long.